Welcome to the Engineering Lecture Series Self-Test 8. The self-test will be on telecommunications network design and management. Your anchor person is Professor Michael C. Ndinechi. We are starting the second phase of self-test on our lectures in the Engineering Lecture Series channel. We use the self-test to see how you have been following our lectures and how well you understand the lectures, by testing you to see how you can answer questions arising from the lectures we have been delivering or you have been listening to. So follow me diligently in this lecture, which is on telecommunications network design and management. It will take us just about 30 minutes to examine and see how much we understand the lectures. Please follow me in the Engineering Lecture Series by subscribing to my YouTube channel. The lecture that covers the questions here is Module 036, and you can reach it using that link. And the title of that Module 036 is Telecommunications Network Design and Management. Question 1 says, state the three telecom management types and their special features. The answer is that network management, telecom network management comes in three forms. It can come as a distributed management type of network, and in this distributed management type, the nodes in the network, that is each station in the network, perform all the functions of the network. Every node has to know everything about the network, things like the routing pattern, the topology, the connectivity, the priorities, and the resources, and any other thing has to be resident in each node. The second one is it can come as a centralized management type. This requires very little activities at the nodes. With centralized management system, one station acts as the supervisory station and controls the entire network, and other stations must receive permission from it in order to transmit their own data. Now, this centralized system has some advantages. One is that few problems arise in coordinating the activities of the multiple stations. Two, more options in terms of prioritizing access or guaranteeing access to each station. And three, less logic circuitry in individual stations, thereby simplifying their interface to the network. Then, third management type is the center-weighted management type. And the role of this center-weighted management architecture is to combine the advantages of the features of the distributed and the centralized management system. Therefore, the network assumes all aspects of both approaches, the responsibility for controlling the network is divided between the nodes and the management type. So you see the three of them: distributed, centralized, and the center-weighted management type. We've seen their advantages and disadvantages. Question 2 says, what are the goals of a typical telecommunication network design? Of course, when we use the term telecom, it is already understood that we mean telecommunication. So what are the goals of this telecom network design? If you set out to design a network, what are the goals you are looking at? We start by saying that the telecom network design goals must aim at providing a cost-effective arrangement of the links and the nodes, and must meet the following standards. The first standard is the traffic volume. The network you are designing must be able to handle a specified level of data traffic without becoming congested. 2, the connectivity. All users must communicate only with the proper resources to avoid illegal connections or illegal resources. Your design must be able to handle fault tolerances. So the network must meet a specified level of reliability as defined in the design criteria. Again, the network must accommodate various communication protocols and data transmission equipment. That is what we refer to as your design has to be versatile. 3 says, what do you understand by telecom life cycle? What do you understand by telecommunication life cycle? In our lecture, we've said why this life cycle is very important when you design your telecom network. We say the telecommunications network life cycle refers to the complete set of stages that the system goes through from its initial concept to its replacement. It involves 1, planning and resources and requirement analysis, 2, design, 3, deployment, 4, operations and management, operations and maintenance, and 5, decommissioning. As we go on, we will see what is involved in each of these requirements of the telecom life cycle. 9. In defining a network life cycle, it makes more sense if the description is carried out focusing on an aspect of this telecom network design. As the network grows, as more people join, as the year passes, new data communication equipment and/or circuits are introduced. As network requirements change, existing data communication equipment are expanded or reconfigured. It grows to a point where the existing data communication equipment and/or circuits are no longer adequate and has to be replaced with more modern and probably higher capacity ones. So as you do that, you get to the point where you will have to decommission the network by migrating to a newer technology. Question 4, state the descriptions of what are involved in each of the phases in the telecommunication network life cycle as outlined in the last question. The descriptions of what are involved in each of the phases. There, in question 3, we've seen 3 phases which we call planning and requirement analysis. So what is involved there is that you must first state the objectives of what you want to, what your network will provide. Things like the coverage, the capacity, the cost, and the quality of service you intend to provide. Then you have to look at the market analysis. Who are your competitors? What are the regulators saying? What demands will your user be making out of your network? Then you go ahead to do some feasibility studies, looking at how to source the finances, the environment you're going to operate on, and the technical know-how which you are going to deploy. After that planning and requirement analysis, you move in to do your design. When you start your design, you have to select the technologies you have to use. For instance, how are you going to provide connectivity? You want to use multi-protocol label switching type. How are you going to transmit your signal? Is it going to be through microwave or through fiber optics? What network, what technology are you going to use? Is it going to be 5G, or you want to use 4G or LTE? So these are things you put in your design. Then what type of topology you are going to use? Is it going to be hybrid? Is it going to be mesh? Is it going to be star topology? Then what is going to form the core and the backhaul? That is how you move information from one point to the other. Then you have to talk about the capacity and traffic engineering, things like quality of service you want to provide, what are the bandwidths that are available to you. Are you going to provide some level of redundancies, that is having parallel working channels in case of failures? Then what equipment are you going to use, and the possible vendors from where you can source the equipment. So the third one, which is deployment, you have to think of how to procure the equipment and the software, how to do the installation of the infrastructures, things like where you will set up your towers, your base stations, the type of cabling and routers you are going to use. Then how are you going to integrate this your design, this your own network with existing networks? Then you have to do some level of testing. In that testing, you will see how the interoperability of your own design with other networks will work, the functionality of your network, and how it complies with regulations and other set standards. Then the fourth one is operation and maintenance, otherwise known as O&M. Here you have to, work out on how to monitor traffic, how to isolate faults, and how you're going to keep your key performance indicators in place and in check. Here also, you have to know how to carry out routine maintenance, things like software updates and hardware checks. Then you also have to look at how to support your customers and improve service quality to them. You must talk of how do you bill them. That is your billing standard, how to account for each person's use of the system, and how to report back on what is happening in your network. And finally, there you have to talk about your security management. More especially in this area of cyber threats, you have to be security conscious. And finally, you have to go to decommissioning. By decommissioning, we are thinking of decommissioning of old equipment. Like we said, as time moves, new data control equipment will be coming out. So as they come out, you replace older ones. So by replacing that older ones, you are decommissioning some of the equipment. Then you also, as you decommission those old equipment, you'll be thinking of how to migrate your users to newer networks. Then you talk of your asset recovery. That is, those ones you're decommissioning, are they going to be reused? Are you going to remodernize them and they are still useful for one thing or the other? Are you going to sell them or are you going to recycle them? Then you document the lessons you have learned. That will help you to, upgrade to next phase, so that if there are mistakes, you don't repeat those mistakes when you are going to, higher technologies or using newer equipment. 5, states the 5 basic categories of telecom network topologies, outline their special features and uses. And of course, we answer by saying that we have identified 5 basic categories of network topologies. They are star network, ring or loop network, mesh or distributed network, hierarchical or tree network, and bus network. Of course, we say that this can come in any combination, and when that happens, we call it a hybrid network. But let's quickly look at the features of the different networks, the 5 of them. We start by saying that in the star network, it is used where there is a central switch. They are not usually resident because they have only one route to each node. A breakdown in the central hub causes a blackout in the entire system. This setback is taken care of by the use of redundant hot standby as a backup system in case of failure of the central switch. When we said redundant hot standby, it's like having 2 working channels, so that when one fails, the other one takes over quickly. Because in the star network, we say that immediately the hub fails, the whole system fails. There will be a blackout in the whole design. So you try to provide, a second central hub which is redundant but takes over immediately the one you are using collapses. So star network are best suited where the communication facilities are separated by large distances. Message delay is likely because of the throughput limitations at the central hub, leading to queuing. What we mean here is that if all the nodes are bombarding the central hub, you can see that there will be delays, and it takes some time before every node is attended to, because they have to queue for their turn, and that is a major limitation and affects the throughput, which is the efficiency of the network. The second one is the ring network. The ring network is important and mainly used for local area networks. Each additional node involves system disruption, thereby reducing performance. If you're using a ring network, immediately you want to upgrade by adding an additional node. Then you have to shut down the whole system to be able to add another network. So you see that affects the efficiency of the network or the uptime of the network. A ring network is vulnerable to a single break in any of the node or link. Anytime there is fault in any of the nodes, if you are using the ring network topology, your system will be affected because there will be no continuity. So it is more demanding to manage a ring network. The next one is the mesh network. In the mesh network, which is also called distributed network, they are most suited for long distance transmissions between nodes and act as message circuits or packet switches. It can be regarded as an extension of both the ring and the star network. Message delay is usually high because of long distance transmissions. That is, because it is for long distance transmission, there are need for repeaters. And as your signal travel and get translated at the repeaters, it introduces some delays. And there will be signal distortions and degradations due to fading and interferences because of the distance you are going to cover. Then the hierarchical network is often referred to as the tree network. That is, it goes from down, more networks. As you go up, it tappers to main network, and that is a good replica of the public switch telephone network, where you have the local exchanges, the tandem exchanges, the trunk, then you get to the international gateway. So here you say that they are in hierarchical order. The single point of vulnerability in a hierarchical topology is the node equipment, which is usually duplicated. Message delay is reduced when independent channels are operated in the frequency division multiplexing mode. I hope by now you know what FDM means. Finally, here we have the bus network. The bus network are usually used for baseband, local area networks, and point-to-multipoint terminal clusters. Convince yourself you know an example of point-to-multipoint communication system. Efficiency is determined by the medium and the access control mechanisms. Efficiency generally decreases as the number of stations increases. In bus topology, as you increase the number of stations or nodes, then the efficiency of your system decreases. New stations can be added without reconfiguring the network. Message delay in token passing buses increases with the number of stations and sometimes with traffic volume. 6. State some possible ways the telecom topologies mentioned in question 5 can be connected in form of a hybrid telecom network. What are the major determinants in adopting a particular hybrid network? In our lectures, we've said that the 5 topologies can be, connected together. Some can be, put together when 2 or more of those bus topologies are employed in a particular network. We say that that network is in hybrid form. And our question here is for us to state possible ways. So we answer by saying that the hybrid network is a particular network in that the benefits of all the 5 network topologies explained earlier can be merged to make a hybrid network. They can come in the form of a ring topology wired in a star topology, a modified ring using a central ring of wiring hubs, a modified ring in form of a loop, so on. But however, the decision to adopt any configuration depends on the combination of the following: the operating budget available to you, that is how much money you have to spend, the topography of the environment, the anticipated volume of traffic, and each topology has its advantages and disadvantages and may be evaluated in terms of efficiency, which is also known as the throughput, the maximum distance you want to cover or your signal will move, the maximum allowable number of stations that you can put up, and the vulnerability to link or equipment failure, then message delay that is tolerable, and the cost. 7. What do you understand by telecom network management? What are the typical features expected from each of the network management system? The answer to the question is that telecom network management is the process of planning, monitoring, controlling, and maintaining telecommunication networks to ensure reliable performance, efficient operation, security, and quality of service for users. The typical features expected in any network management system are control, management, and design. Under the control aspect of the network management, we say that the control are the normal operational functions that must be outlined at all times, as well as all matters relating to the network topology and connectivity. And these include call setup, call takedown, automatic alternate route, bumping, configuration, diagnostics, and alarm reporting. These are the things that you take care of under the control aspect of network management. Under the management proper, you say that you take care of things like the inventory, trouble tickets, vendor files, user records, historical statistics. Now, for instance, your user records, you have to know how often they use, what they do when they use the network. You have to get them down. Trouble ticket, for instance, you have to know where failures occur most often so that you'll be able to know what causes the failure. It helps you to fix them quickly as they occur in any other part of the network. So the last there is the design itself. I say that this helps in setting up of the initial network and evaluating proposed changes. In our question 1 here, we've talked about, what network design is all about. So in the design, you must talk about the typical tools you have to use here, which include traffic or tariff analysis, how to, document your network design, your tariff files, and the node designs. Like we've seen, if you are using distributed or centralized design, you see that you will have a central node, and that other nodes will just be, having minimal circuit just to connect to the main design. It says, why is the knowledge of life cycle concept very important in telecommunication network planning? Very important for you to understand this, that the life cycle of any telecommunication network is very, very important when you are planning to roll out a telecoms network. So we answer by saying that the life cycle concept is very important in telecommunication network planning because it provides a structured way to understand, design, operate, and maintain complex telecom systems throughout their entire existence. The key reasons are for systematic planning and design. Under that, say that because telecom networks are complex and capital intensive, you have to be systematic in designing and planning it. The life cycle approach helps in breaking down activities into phases. Phases like planning, design, implementation, operations, and retirement. This ensures that requirements such as capacity, scalability, reliability, and cost are factored in early enough in your design. Second one is efficient resources utilization. When you are looking at the life cycle of your telecom network, you will call to mind that they require large investments in infrastructure. For instance, if you're going to do your transmission using fiber optics, you know the cost. If you're going to, have base stations along the routes, you know how it takes to, establish a base station. Then what of the routers? If you're going to make use of satellite communications, you have to think of how to lease satellite transponders and so on. So it is capital intensive, and you must understand how and plan efficient resources utilization. See, are there places where you are going to share facilities like base stations? So understanding the life cycle ensures that investments are allocated wisely and upgrades and replacements are planned at the right time. Then next phase you have there is for technology evolution and upgrades. For instance, as technologies evolve from 2G to 3G to 4G to 5G to 6G, you should be able to upgrade with ease. So life cycle knowledge helps engineers plan migration strategies so that existing infrastructure can support future upgrades without complete redesign. Have to be thinking of operational reliability. So during the operation and maintenance phase, the life cycle model ensures continuous monitoring, fault management, and service optimization to keep the network reliable and available. Then you talk of cost management. The life cycle approach allows for total cost of ownership analysis, covering not just deployment costs, but also maintenance cost, cost of upgrades, and cost of commissioning. We have seen before now what this commissioning means, where you remove obsolete items or equipment and add more modern equipment. Say you decommissioned the old one. This prevents overspending and reduces financial risks. Then talk of the regulatory and standard compliance. Remember, telecom is regulated internationally, so you have different levels of regulations. Your government can regulate you, then the international, regulating agencies like the ITUs always specify some standards in order to ensure interoperability. So you must be able to, see that your network comply with these international standards and government regulations. The life cycle model embeds compliance checks at every stage to avoid penalties and ensure interoperability. Then you have the phase which is the risk mitigation phase. So you must be able to identify risks, that is technical failures, obsolescence, cyber threats, and so on and so forth. And when you do, you must consider it over the entire life cycle of your network. Proactive measures can then be built into the design and operation phases. And finally, we look at the sustainability and decommissioning. Say that at the end of any network's life cycle, equipment must be decommissioned, and you must do that responsibly. Life cycle knowledge ensures proper disposals, recycling, or reuse, aligning with environmental and sustainability goals. So you see that when you are planning your telecom networks, you must have in mind what is the life cycle of this network. When am I going to start upgrading? How do I decommission, the equipment when they are old enough and they become obsolete? How do I follow regulations to make sure that I don't incur the wrath and penalty of the regulating bodies? And of course, what is the total cost of ownership of this network? So when you do that, you see that you have mastered, things about telecom network design and management. Thank you for joining us in this self-test revision. We hope you find it very useful in understanding what we have done. Thank you.